and not the cloud substitution method. Suppose you have the following integral. The integral of 2 times 2x plus 1 to the third power dx. How do you take this integral? To take this integral, we're going to use the method of substitution. We observe that 2x plus 1 inside parentheses has a derivative, which is 2. So by using u sub, u is equal to 2x plus 1. And if you take the derivative, du is equal to 2 times dx. So basically, you have 2 dx in your integral, and you can use u sub method. This is equal to the integral of, this is u to power 3 du. But remember that to calculate the integral of u to power n du, it is equal to u to power n plus 1 divided by n plus 1 plus constant of integration. This is what we learned before. So now this is equal to u to power 3 plus 1 or 4 divided by 4 plus constant of integration. Now you just need to do the substitution again. U is equal to 2x plus 1. So this is equal to 2x plus 1 to the 4th divided by 4 plus c. So as you can see here, 2 and dx, this is your du. So wherever you see 2 dx, you're going to use du instead. Another example for you using substitution. Suppose I ask you to calculate the integral of 10 e to power 10x dx. We're going to use the method of substitution again. Please note that here the exponent is 10x. Since the exponent is 10x, we're going to use u to be 10x. So let u to be 10x, du is equal to 10, and it has dx next to it. Perfect. So take a look. We have all the missing information here. This is 10 dx, which is equal to our du. So this integral is equal to the integral of e to power u du. But remember that the integral of e to power u du is equal to e to power u plus constant of integration. So this is the formula that we learned for exponential function. This is power function, and this guy down here is exponential function. So let us continue our process. The integral of e to power u is e to power u plus constant of integration. But our u is 10x. We need to replace this guy back into the exponent. This becomes e to power 10x plus constant of integration. Let's make it more interesting for you. Suppose I ask you to calculate the integral of cosine to power 3 of x times sine x dx. How do we calculate this integral? Again, we're going to use the method of substitution. What are we going to use as a substitution is cosine u. Why? Because it has an exponent, right? Let u be cosine of x. Then as you remember, du is negative sine x dx. One shortcut or algebra is saying that, hey, dx is equal to du divided by negative sine x, and do the substitution here and cancel out what's left. Sometimes it's working, sometimes it's not working. The main point is to recognize what is inside the integral that you can use. So again, one shortcut is writing dx as du divided by negative sine x. So since you have sine x here, sine and sine, they get canceled out. But sometimes you don't have that quantity inside your integral, and it causes confusion for students. Okay. So take a look here. If I write dx as du divided by negative sine x, I can cancel out sine and sine, but note that I need to be careful a little bit about the domain as well. So this can be written as the integral of your cosine is your u, so you can just write it down here as u to the third, and you have sine x, and dx, which is du, divided by negative sine x. These two, they get canceled out. But again, pay attention. If sine x wasn't here, you are not allowed to do that. You cannot create another sine x inside your integral. Very good. In terms, this is equal to negative integral u to the third du, which in turns is negative 1/4 u to the fourth plus c. But u is cosine x, so substitute it back, negative 1/4 cosine to the power 4 of x plus constant of integration. So I gave you 3 different examples using u sub. So let us make it more interesting for you. Let me go to the next line here. Suppose I ask you to find the integral of x divided by square root of x plus 1 dx. How do we compute this integral? What is a good substitution here? So the substitution you might be interested in using is looking at the quantity inside your radical and use that as your u. So let u be x plus 1, then du is equal to dx. But this substitution helps you to rewrite the numerator as well. On the numerator, x is equal to u minus 1. So we can rewrite this integral as the integral of u minus 1 divided by square root of u du. So now you have 2 quantity on your numerator and 1 quantity on the denominator. So basically, you can divide up this fraction into 2 fractions and deal with that a little bit easier. This is equal to the integral of u divided by square root of u du minus the integral of du divided by square root of u. This is basically what we did before. If in general we have the integral of u to power n du, this is equal to u to power n plus 1 divided by n plus 1. Right, there we go. Let me close close this up and go to the next step. Now we need to simplify this further. This is equal to the integral of u times u to power negative a half du minus the integral of u to power negative a half du. If you combine these two together, you get the integral of u to power a half du minus the integral of u to power negative a half du. In turns, it's equal to u to power a half plus 1, which is 3/2, divided by 3/2, minus u to power negative a half plus 1 is a half, so you get u to power a half divided by a half plus constant of integration. So in turns, it's equal to 2/3 times u square root of u, or since u is x plus 1, you get x plus 1 times square root of x plus 1 minus 2 times square root of u, which is square root of x plus 1 plus constant of integration. Make it a little bit nicer so it's readable for everybody. So using use of helping us to calculate this integral, which is x divided by square root of x plus 1, using a new variable, new parameter, and helping us to calculate this integral a little bit easier. You could factor out 2 times square root of x plus 1 and simplify this further, or you can basically leave it as it is.